What's up, folks? Thanks for tuning in. So, where we left off, I know it's been a while since we had these night sessions. So, where we left off, we were still at the layer two of the OSI model, right? And so, the topic at layer two we were discussing was spanning tree, right? One of my favorite topics, and one of the core essentials that I like to tell people to learn before they even think about learning anything at layer three, like any dynamic routing protocols, any technology that exists at layer three that expands across the WAN or et cetera, right? Because there's been many cases where I've seen that folks are troubleshooting layer three, go straight to layer three in regards to troubleshooting all day, every day. Come to find out it's either a layer two or a layer one issue, right? So we are going with the fundamentals, we are going with the basics, and this is where we're starting. Okay. We talked about the three major functions of a switch, right? To learn MAC addresses based off the source MAC address, right? To send MAC addresses, based on the destination, right? And to prevent loops using spanning tree. Okay. And so what I wanted to do during this session is I wanted to go ahead and break spanning tree. Last session, we went ahead and converged the topology, right? Thanks to Patrick and to Marquisha, we went ahead and converged it, right? And as you can see, we have our root bridge, we have our our designated switch and our non-designated switch, right? That non-designated switch has that blocking port, so you see that BP, right? And of course, our designated switch has RP, stands for root port, and our DP means designated port, right? So, and of course, there's a root port here on a non-designated switch, right? And of course, our root port has all, not labeled, but all of their ports are in a designated port state, and it's in a forwarding state, okay? So we have that established, right? We have that good. But what actually happens when we have, a spanning tree loop, right? So let's go ahead and give it a shot, right? So how are we going to break spanning tree? So we are going to do this. We are actually going to turn off spanning tree, right? And with Cisco, by default, spanning tree is on, okay? And so as soon as you power up a switch, out of the box, spanning tree is on. So what happens when we turn it off, okay? So I'm going to go ahead and turn it off on each switch, okay? Give me a moment. Spanning tree, one, okay. Spanning tree, one, okay. All right. So we went ahead and knocked it out, right? Let's go to the X root bridge, right? And let's take a look and look at that spanning tree configuration. Okay. All right. So of course, we trust but verify. Went ahead and verified that spanning tree is not enabled on this switch. Okay. So we got it up and running. So now what's going to happen if packets are, if PC4 tries to ping PC5? Let's see how that looks like. So first things first, we are going to do this. We're going to set up some packet captures. Okay. And I want to do a packet capture on switch one, right? We're going to do it for both ports. All right, and it looks like both of our ports is gigabit 0/2 and gigabit 0/3. So I'm going to set up a /2 first. Let's wait for that to pop up. And guys, by the way, if you're wondering what this program is that we practice on, I know it's been a while. It's EVE-NG, probably one of the best programs you can use to learn about networking, security, etc. Me personally, it's better than GNS3. It goes really in depth. So if you're thinking about investing, definitely go with EVE-NG. You just have to make sure that you research the resources that you will need, and of course make sure you hook up your box with a lot of specs, and yeah, you can enjoy. So let's go ahead and try to pop this packet capture again. All right. Okay, let's try it again. There we go. Okay. All right. So I'm going to put it on a different screen, right? So we're capturing, right, on gigabit 0/2. And actually, what I'm going to do, I just thought about it to correct myself. I'm going to capture on each port, right? So we're going to, on each switch, right, on one of the ports. So I'm going to capture on gigabit 0/0 as well. Okay. And as you can see, 0/0 was our previous blocking port. So I want to see what happens, right? I want to see what happens whenever we get it going, get it running, and we shoot a ping out from one of the PCs and see if we have different behavior. Okay. All right. All right. So we got that capture running. All right. And last but not least, let's capture this on the uplink going towards switch 1. So let's do 0/2. Okay. All right. So we got it rolling. So now that we got our packet capture rolling, cool, where we're seeing that traffic. Now, the first thing we're going to do is going to cut on the PC and we're going to configure it, right? And I know this is CCNA, but just want to teach you guys something about ARPs and GARPs, right? ARP being address resolution protocol, right? What it does, it maps the IP address to a MAC address, right? Well, within each PC, they have ARP technology built into it, but every time an IP address, right, is configured on a host, right, it's going to do something called a GARP, meaning a gratuitous ARP. What does that mean, right? Big words, right? Gratuitous ARP, what it is, or a GARP, is it's announcing itself on the broadcast domain, right? What is the benefit of that? It's making sure all the devices within the broadcast domain, A, knows where it lives, and B, doesn't assign that MAC address and that IP address to another host if DHCP is involved. Okay. So let's go ahead. I'm going to go ahead and assign an IP to it. Let's just check that config. Okay, there's nothing there. So let's do something simple. 19.68.1.50, 255, 255, 255. We're gonna make it a /24, and no gateway. We're fine, right? Because again, they're on the same broadcast domain, layer 2, so we're all good. Now let's go ahead and pop open PC5, right? So remember what I told you guys about that GARP? You see it rolling, right? See it rolling. It's still sending it. So that was a quick preview. And we're going to talk about it in a little bit. And remember, we still have spanning tree off. Okay. So let's go ahead, check the config. All right, nothing's there. And let's go ahead and configure this bad boy. Call it 100. 5, 5. Okay. All right. So a GARP should have been sent from PC5 as well. Right. Let's go ahead and take a look. Right. All right. Hopefully you guys can see what I see. Okay. All right. So this is where we start to break stuff. Okay. Let's go to the packet capture on, this is for switch 1. And let's go ahead and grab PC4 and try to ping PC5. All right. Let me pull up PC5 over here because I really want to break the network and I want to go ahead and ping them both at the same time. All right. And 100 and ping 192.168.1.50. Okay. All right. We got pings rolling. All right, we got pings rolling. And I think these are gonna keep rolling. Perfect, perfect. All right, so you guys see it, right? You guys see, let me go ahead and zoom in, right? You see there were ARPs sent out, right? ARPs sent out, right? There were responses to those ARPs, but it's continuously going in a circle, right? Let's go back. Switch one's packet capture, right? Off of gigabit 0/2. You see, ARPs are just continuously going in a loop, continuously going in a loop, right? Typically, if spanning tree was here, the ARP would have been sent out, a ARP request, right? Then it would have been a ARP apply, right? From the host, and then it would have been done with it, right? The network, the topology would have had one way of passing traffic. There's multiple ways to get to both hosts now, right? And there's no spanning tree to prevent that loop. So you see, right? Let's go ahead and move over to switch two. Same thing. It's going in a circle. It's going in a circle, right? And again, we're sending pings. And you guys are probably thinking, well, if we're sending pings, why, why is it, why hasn't it, why hasn't it resolved yet, right? Or why we don't see ICMP, right? Both of these hosts don't know, don't know where each other live, right? And we're using the switches to go ahead and connect both of these hosts together to put them on the same broadcast domain. With no spanning tree, first we need to go ahead and do an ARP, right? And see where it lives before we can go ahead and start passing that traffic. As you guys can see, just continuously sending that ARP. And let me go ahead and make a quick note. ARPs are broadcast messages, right? So it's sending out through all interfaces except the source interface where it received it on that switch. So it's going to send it out all ports, right? So again, each switch is doing this. Each switch is doing this, right? And I'm sure you guys saw that quick blurb, right? There was a quick reply, right? Quick, yeah, right there, right? Right. And so we see that right there is a quick blip, but again, it's not resolved, right? This is a broadcast store, right? And again, this is just with two PCs. Imagine, right? Imagine if we were on a network, right, in a production environment, and it was, I mean, almost 200 PCs. The network would literally break. The network would literally not know what to do. Okay. So what are we going to do? Let's fix this, right? Let's fix our network, right? Look at it, right? We can see even the switches are it's crashing. Whenever you see the thing trace back, right? That means the CPU is absolutely high, right? It's unfunctional. I can't even touch the CLI, right? So let's go ahead. Let's go ahead and stop those pings, right? Because our switch can't even function. Okay. Let's go ahead and stop it. Let's get into this switch. Yeah, you see it, right? And look at these processes, right? Ethernet timer CFA, right? Load meter. These are things that are beyond the CCNA, but these little things tell you. These little things tell you it is, right? CPU is spiking high. We can't even touch the device, right? It's going crazy, right? And how would we resolve? How would we typically resolve a broadcast storm? Unplug something, turn something off, et cetera, right? So let's go ahead, right? Because these ARPs should stop soon. But again, you guys see it, right? You guys see it. Loop, right? The traffic is going on and on and on, right? On and on and on, doesn't stop. We've been stopped the pings, but it's continuously going and going and going. Okay, so we're gonna go ahead and we may have to get into the switches and either A, turn them off, right? Look at it. This is switch 2 we're looking at, right? Same thing. We absolutely did what we wanted to do in this lab. We broke the topology, right? We caused a spanning tree loop. Okay. And so now that we have this, right, in the real world, how to fix a spanning tree loop, you start unplugging things, right? You start unplugging things, you start unplugging thing, or you reboot it. Of course, you wouldn't, either way, end users are going to lose. They don't have access. They don't have network access in the first place with this broadcast on, right? So you want to either reboot the device, unplug some cables, right? Of course, take your time, and then see where your issue is at. So I don't want to turn off the switch. Let's go ahead and start unplugging cables. Okay. So got our cable here. Let's go ahead and delete that. And we got our cable here. All right. And let's delete that. All right. And again, we're virtually being those network admins where we're just removing cables, right? Let's delete that. Okay. Now let's go ahead and check our switches, right? Let's check our switches, right? And woof. Okay, look at it, right? Look at this, look at the syslogs, right? It's telling us the CPU was absolutely high, right? It was absolutely high, right? These different processes, they're high because again, the switch was working very, very, very hard, okay? Because of spanning tree, right? You can see it all over the place, right? Now we have access to our CLI now. As you can see before, whenever the broadcast storm was happening, it's continuously, going all over the place. So now let's see what it looks like if we go ahead and re-enable it, right? Okay. All right. And let's verify, right? Because we always want to verify whenever we put something in. Okay, perfect. So we got spanning tree rolling. Okay. Let's do the same thing on this one. And this is switch 2. Whoop. And 1. Perfect. There we go. We're going to save that config. All right. So there we go. All right. All right. So we got spanning tree rolling. Last but not least, well, we know spanning tree is not rolling. We need to configure it. Spanning tree VLAN 1. Yeah. Okay. All right. So we have it rolling. Let's verify on switch 1. I believe this is our last switch. We need to configure it on. Okay, perfect. So we got this rolling, right? It's all good, right? Now let's connect everything back up, right? Okay. Doesn't matter. We're all good. It doesn't matter which port. I'm okay with it. Let's plug it back in. Okay. And typically in the real world, right, you wouldn't instantly just plug everything back in, right? You got to trace the problem, right? You identify with your topology, you see where everything's plugging at. You see, of course, some of the syslogs you research, what have you, before you jump ahead and bring the network back up. Because the worst thing you want to do is spend more time troubleshooting. Okay. So we have this rolling, right? Let's get back up to switch 1, right? The interface is popped up. Okay. And let's go ahead, let it converge for a little bit. It shouldn't take that long. Okay. All right. And while I'm letting that build up and rebuild the topology, I am getting a command for the CPU because I actually want to show you guys the CPU and how that looks like. Okay. Give me 1 second. Give me one second. I didn't want to do debugs during this exercise because that would have made things absolutely worse. So, okay, bear with me, folks. There we go. Okay. All right, so we're good. All right. Clearing some things out. Okay. Right. Let's go ahead and check spanning tree on switch one. Okay. All right. So switch one is the root. Okay. Just like how we had last time. Okay. Let's go ahead and, of course, with the root, all of its ports have a designated role and its state is forwarding. Okay. Let's go ahead and check switch two. All right. So spanning tree. All right. VLAN one. Okay. All right. All right. We're looking good. So no blocking ports, right? This is the designated switch, okay, within the topology, right? So we have our root port identified and we also have our designated ports, okay? And the non-designated switch, which is switch three, right? Just like how we converged last time, it should have a block port, and that should be gigabit 0/2. Boom, 0/2, just like we did it before. Okay, so let's go ahead, right? And it hasn't been 5 minutes. Let's take a look at that CPU, right? So processors, let's take a look. All right. Yeah, doesn't actually give it. Let's go ahead and end that. And actually, show processes, CPU. There we go. And okay. All right. All right. So let's take a look at this. You guys see that? Right? We never want our CPU to touch 100%. That means it's at capacity and the switch is just going to stop working. Okay. So we can see how to read this graph, right? This shows us in the last 60 minutes, showing each minute, right? And we can see, boom, right? It touched 90 whenever we had that loop going on, that traffic going on and on and on and on and on. Okay. And so, once we saw that rolling or what have you, this is why the switch became unresponsive, right? Layer two was working on the switch and it had to work very, very hard because again, it's getting the same packets. It's getting packets back and forth and back, right? No, spanning tree is not mitigating that traffic, and there's no one-way flow of traffic. Okay, so this is one of the effects, and this is the reason why we couldn't get into the CLI. We couldn't touch the CLI because the CPU was hogged, right? With that traffic that was passing. Okay. So once we have that there, right, and of course we see that traffic is, we see the switch is back stable, the topology is back stable. It is using spanning tree now. Let's try to ping between these two devices. Okay. We're successful, right? Back and forth, we're successful, right? We're seeing that through and through. Okay. Requests and replies, we see it. We're good to go. We're good to go. So hopefully this was fun. Hope it was fun for me. Hopefully this is helpful for you guys. And if you guys ever want to emulate this in your lab, you can. Okay. Thank you guys for joining in. You guys have a great day.